All right, hi, thanks for coming. We're going to go ahead and look at number 6. For number 6, we are looking for what is the minimum and maximum that the third length could be. So truly, you simply subtract to find out, or actually, my bad. I wanted to do it the other way here. You're going to add to find out the maximum and subtract to find out the minimum. So as long as it is less than 29 and greater than 7, then that side will work. Let's go ahead and look at 7 now. For 7, we want to figure out what the angle DFG is equal to. So the first thing we need to do is set up a little equation, and the complete reason will be parallel lines imply corresponding angles are congruent to each other. Name, relationship, condition. So I set them equal to each other. And I solve by subtracting my 9x, and I solve by adding my 19. And x is equal to 60, but I needed to actually, not 60. Just kidding. I thought that was a little strange. X is equal to 6, so I plug it in here. So I have 9 times 6 minus 7. So that's what 54 minus 7 is equal to 47 is our angle. All right, let's others. Number 8. This is a good one. Let's change my color. So for number 8, we want an equation of a line that is perpendicular. Well, this is the slope of my original, so my new slope should be the negative reciprocal. And if I want something that is passing through this point, that's actually the y-intercept. So in actuality, I really am done, because this guy here is my y-intercept that I'm doing. All right, let's look at another example. Number 9. This is a good one. So we have all sorts of things going on here. We can start a lot of places, but, well, let's just start here, just for the sheer fun of going straight to z. So I need to subtract from 180 because those guys are linear angles. And so this one here would be 114. Okay, so that one is 114. And let's look here. Ooh, this is a good one. If this is 42, I hope you can see it. We've got our little situation going on right there. So if that's 42, then this is also 42 because of our alternate interior angles. And then we can figure out what this one is using our either same side interior or linear here, kind of depending on which one you want to do. And that would be 138 would be equal to W. Now let's see what else we can do. We can figure out what this angle is right there. I'll do the math right over here. We have our 180 minus 66 and minus 42. So that's 8. That's what, 2. And then 7 minus 10. I really need to do math better on that. Let's go ahead and try doing a different little format of math because my brain is not working that way. All right, so let's add 42 and 66 first, which is 108. So then 180 minus 108 should give you 72. Yeah, 72. So that means that this guy here is 72. So that meant that this one here must have been 108. And I like this one and this one being equal to each other because those are corresponding. Hopefully you see that. Here's our line. Here's our parallel line. And these are both in those same positions. So that means x is equal to 72. All right, it looks like we're going to do 10 next. All right, for 10, finding the area of the trapezoid. Formula. This isn't working very well. There we go. And so when I do that, I would get, what, 12 for my height. Base 1 plus base 2 is equal to 31. So I can cancel. This is 6 times 31, which gives me 186 for my answer. All right, let's look at 11. 11 is finding the measure of the obtuse angle. So the first thing I need to do is figure out what x is, and I need to not set them equal to each other because they don't look equal to each other. I'm also not going to set them equal to each other because they are supplementary, which means they add up to 180 because they're linear angles. So I have 5x plus 10 equals 180, 5x equals 170, and x goes into, what, 336. So for the obtuse angle, I would need to multiply that by 4. And gives me, what, 24, 144. And 144 plus 12 is equal to 156. And for the complete reason, I would use linear angles are supplementary. Last but certainly not least, we're finding the area of the given triangle. This, my friends, is the base, and this is the height. So we need to take half of the height, which is 3 times 17, which gives me 2151. So 51 square units is the area of that triangle. Thanks for coming.